Hello and welcome to my DS4100 final project presentation. I'm going to be walking you through my cleaning, integration, and analysis of fantasy football data. So starting off at the top, we begin by importing some libraries that'll help us in acquiring the data, manipulating it, cleaning it, shaping it, putting it in a database, and then ultimately putting it into a model. So first off, we're going to be putting our CSVs into raw data frames. So these three CSVs were acquired from a web scraping tool called import.io. Pictures detailing the process are included in the presentation in the zip file. I'm sorry. So this is the URL from where we got the data. This includes just the quarterback. We have the top 50 players for three positions: quarterback, running back, and wide receiver. These are most comparable to each other and have data that are pretty similar to each other and how they score points and the amount of points that they score. So before we begin, we're going to have to make some changes to the data. It didn't come in a perfect way. So we begin, as you can see right here, there are different number of columns for our different raw data files. So we're going to add some zeros in where they're necessary and take a column out where it's necessary so that they're all the same length. Now this is important to do because it might seem like these zeros are not necessary, but the reason is that they're three different positions, and so when we look at the data in its entirety as all three of the positions, you need those zeros to keep them comparable to each other. So once we have all those column names, we can give them the column names and combine them into our data set. So fantasy is the data frame that we're going to be working with. So URL and injury are not necessary columns. Injury is a column that doesn't apply to most of the data. Most of them are empty, while URL is available through the README and is not really relevant to analyzing the data itself. So here you can see from head fantasy the beginning. It's not perfect data clearly. We have some commas, need some formatting. This is two columns in one column. This is the same thing as a ratio rather than two individual columns, so we're going to be working on that next. So in order to fix that column, as you see here, first we're going to acquire that column, replace all punctuation with an empty space. So that's talking about this comma, and then trimming the white space in between the comma and the team name. Then we have a little bit of substringing from available to find first everything except the last two characters is the team name, and then only the last two characters is the position name. So we can bind those columns into fantasy and then remove the combined column that has both of them since that's not relevant anymore. Then we have the completions and attempts. That was the column with a slash in the middle. We can use the separate function to separate that into two different columns. So these are the columns that we manipulated. Everything's nice and clean, easy to see what we're looking at. So because the website that we got from was filled out completely, there aren't any NA values, and I made sure that was true when I scraped it, but it's also important to check for that right here. So if we gather all the NAs from fantasy, it's clear that there aren't any, so we don't have to worry about any data imputation. But this is a worthwhile step in making sure that we don't have to do any data imputation. So although we do have all the data, we still want to check for outliers, see if there are any records that do not apply. So we are using the 3 standard deviation threshold away from the mean, and we can apply this outlier to multiple columns. So this function, find outliers, applies the 3 standard deviations to the mean, checks if it's anywhere outside. As you can see here, there aren't any outliers in these relevant columns. Now, so we're going to add some more columns that are derivative of the columns that we scraped from the internet, from the raw data. So the first one we're going to do is attempts. Because they're quarterbacks, running backs, and wide receivers, they attempt to score the ball in different ways, and they can do multiple of each of these three, and there's no way of accounting for that. So the attempt column will just combine them all and see if the increased level of attempts, and it makes it comparable. It makes it easier to compare running back receptions to quarterback passes to see if attempts has an effect on point scoring. Then we're going to do some simple min-max normalization. This is a simple formula, x minus min of the column divided by max minus min. So here, if you see the head of the points column, you can see that they're just absolute, while here puts them in the range of 0, or from 0 to 1. Now, I wrote this to a CSV just so that I could have this clean data for later use in case there were any problems, but it's not necessary. It is helpful though, and another helpful way to store it is to put it into a database. So we have this database first. There weren't any. Then we write the table, and then we list fields of the table. And here we have all the same column names that we had prior to putting it into the database. So here we have some database queries, simple fetch result function, so we don't have to keep redoing this. First, just to make sure it works, we'll select 5 names, easy. Then we'll see all the players in the top 150 that are New York Giants. We got 4 of them there. Now we'll see which player has the most points by limiting 1 and descending order by points. So Patrick Mahomes has had a stellar season. He's the highest scoring player in fantasy football right now. Next, we can do a little more complicated stuff with this as well. We can get the sum of the points, group it by team, and then order them by team so we can see, or order it by points so we can see how these teams are scoring over the year. So the Los Angeles Rams have the highest points total for all their teams, all their players. Those are just some simple queries to show you that we do have the data in database, easy to query them straight from R. Didn't even have to manipulate SQLite at all. So now that we have the data cleaned, shaped exactly how we want it, we can put it in we can look at some preliminary plots. So first we're looking at points versus attempts for running backs and wide receivers. These are the 2 different types of attempts, and it looks like there might be a positive correlation for each of these. And then because we combined passes, rushes, and completions, we looked at total attempts. You could look at the README to see what this means. And I was looking at this and I saw that it looked like there was a bit of a trend to me. So I grouped it by color for position. And it looks like there's a pretty strong correlation to how your attempts affect what kind of points you get and how many you need in order to score your points depending on your position. So that was pretty interesting, and this is going to come in handy later when we decide what kind of models we want to use. So first off, we're looking at, so we did some exploratory plotting just to see what our data looks like, make sure it is what we expect. Now we can compare, like we did up here, attempts to points graphically. We can compare it using our Pearson-Spearman coefficient. Spearman is more for outliers and getting rid of outliers by using a normalized value, but that's not really relevant here since we don't have any outliers out of our threshold standard deviation. But it's still okay to look at both of them, compare them, see how they compare to each other. So Pearson and Spearman both have a pretty high positive correlation, and both of their p-values are extremely low, so we can say that the Pearson and Spearman coefficients are statistically significant. I was looking at attempts and points, as I said before. So now we're looking at our model. Since we have done some exploration, it is exactly what we want it to look like. Splitting and training the data sets right here. So now you can see that their indices are not in order anymore. Next, we're going to create a linear model, taking out name and standard points since this is tightly fit to points. That's what we want to predict, points and all other predictors using our train function or a train subset. Name is also not going to have effect on train, so we're going to try it here. See, the teams aren't really helpful. It's kind of surprising that Kansas City is a statistically significant way of deciding points, but a lot of these indicators, these columns, are actually directly tied to points, and it's a one-to-one. It's a perfect fit because points are based on these columns. You'll see that in the r squared of nearly 1. So we're going to try to choose predictive columns, not ones that points is actually based on. And when we look at that, you look at predicted versus actual, they come pretty similar to each other based on our predictions, and our all equal gives us a mean relative difference of 11%. So that means on average the prediction is 11% away from the actual value that we're predicting for points. So that's pretty cool. We can see an example of some of those right here. So these points are pretty close a lot of the time based on some data that we acquired. This one's real close. Now, because we had that color-coded graph that we thought looked pretty good, we're going to use a classification model for that. We're going to use k nearest neighbors to use points and attempts. It seemed pretty clear that attempts and points had a strong correlation there, and so using k nearest neighbors, this is our table to show our predictions. We only had 6 off out of 45, which is about a 13% failure rate of predictions, which is surprisingly good based on just these two columns. And then when we break out attempts into its individual combinations and add in some other predictive columns, we drop that down to 2, so from 13% to 4%. Overall, very effective in cleaning, integrating, storing, and then analyzing the data. It was really insightful. Learned a lot about how the different aspects of these players affects their point scoring system, and there's plenty of models that I can create now and different relationships between these variables that I might be interested in looking into later.